By experimenting with recipes and ingredients, basically anyone can learn to cook at home and even get creative making new things. Readily available ingredients and an abundance of recipes makes cooking at home practical. In an analogous way, our goal is to make it possible for anyone to customize their wearable devices to better assist them in their daily lives. What WearScript provides is a broad set of APIs, similar to ingredients, and example scripts, similar to recipes. It's most valuable for prototyping, solving unique problems, and having fun, primarily tasks where the overhead of the normal development cycle gets in the way.
This is Scott. Throughout this video, links to the code for each example are provided in the description. Let's start out with a simple example. I'll show you a fun peekaboo script that uses the light sensor to tell when you're covering your face. I'll use the WearScript playground to find a good threshold value. The image changes depending if the sensor value is above or below a threshold. You can customize the pictures by tapping.
WearScript allows your devices to communicate with one another over Bluetooth or the internet. In this example, I demonstrate using a Pebble and a Mayo that are paired with a phone which controls the glass timeline. Short presses on the Pebble are used for control, and long presses are for changing which input devices are enabled. I made a 3D printed ring that holds a magnet which can be used as an input device. The magnetometer on the phone picks it up, and my gesture detector causes glass to swipe right when it's nearby. Most importantly, you can make one for a few cents, and it works even if your phone is in your pocket. To test this out, I'll play an overly complicated game of Tetris, using each input method only once. The latency is about 1/4 of a second, which is more than adequate. As the input devices emulate the glass touch events, none of the Tetris code had to be modified for this demo. Scott used WearScript's multi-device support to produce an hour-long improv comedy show.
Improv comedy is punctuated by shouted suggestions from the audience. In our show, the audience entered suggestions using a mobile app, and cues were delivered to the comedians on glass.
Periodically throughout the scene, they're going to get some styles or genre on their glass that they are going to use to shift where they are and what they're doing. Do you hear that? No. But I feel it. You feel that? Yeah. Behind the clothes, it's a clue. And a monster! No, save me!
No, I'm sorry. I can only save one of us, and I'm gonna have to save myself.
Wait, no.
Yes,
no, please.
I made that monster. Now I am
The way
the monster.
the way you hold that knife is so romantic.
I'm gonna make love to you, and then I'm gonna murder you.
After the improv show, Scott and I hosted a WearScript workshop at the MIT Media Lab. The first day was an introduction to WearScript. We had stations set up with supplies for participants to experiment with, including eye tracking, home automation, and user input devices like the Pebble and the Mayo. The second day was a hackathon. It was amazing to see the broad range of ideas people had and how quickly they were able to apply what they had just learned a few hours prior. Let's check out a few of the hacks from the event. So, what's the name of your app?
Loveco Forms has built an arousal app today here at MIT Media Lab. Our app uses our eye tracker attached to this glass to use pupil dilation to indicate arousal with somebody once you have passed a specific threshold. Do you hear my eyeglass tracker? Do you hear when my glasses
I don't.
tell
I think
me?
it's a voice inside your head, but you should follow it.
Oh my. It says over again.
Demo. But what was really cool is that like we could like play around with all these technologies and interact with them using like JavaScript, which is great because then we don't have to necessarily interact with like the specific SDKs for every single one. So that made things really, really cool, and we got
quite a bit of code between different components. So we decided to make an actual Pokemon game where you walk around with maybe a Pebble smartwatch, and you just start challenging people to Pokemon battles on the subway. Or maybe there's no internet connection there, but maybe places of internet.
What happens is we have the Pebble smartwatch controlling the types of attacks that you can do. Right now, it is on Charmander, who is fainted. And okay, so my opponent just used Psychic.
Charmander does a fire attack on Venusaur. Venusaur takes a lot of heat. Switch it out for Dragonite. Dragonite kind of just takes out the Charmander, poor little guy.
So we wanted to test out the Myos, which are these myoelectric armbands here. And the way we wanted to do that was use these Hue Phillips lights here. And they can change to any color. And so we decided, hey, let's create a game out of it.
Yeah, it went from like unboxing the Hue lights that somebody just threw over here and said, hey, who wants to hack on these? To like a full, like this demo that you'll see and like total dev time of like 2 hours with WearScript. So you can like rapidly prototype things and get them together.
So the way this works is we have two lights. They're set to a random colors. And the middle light is the target light. So we each have a light, and we're trying to get our light to be as close as that as possible. And when one of us thinks we're close, we'll end the game, and whoever's closest wins. So we'll go ahead and demo that right now.
All right, ready? Go, go.
He wins. I got one. So as you can see right here, we can go ahead and end the game anytime with fingers out like this. We can start a new game with a fist. And then otherwise, we're just waving through like a color spectrum here.
Dude, it works really good.
That's awesome.
Okay, so I feel like I'm just like in the phone, like I'm part of it.
Okay, I'm Andrew, this is Peter, and that's Raj, and this is Antonio. This is a project of augmented reality for Glass. So what we have here, you can see all of these markers on the board in front of us. These are AR tag fiducials. These are little markers that are easy to pick up on computer vision, and each one of them is encoded with a special symbol, so they each have a unique number. What the user sees in their view once a tag is detected is it overlays right on your screen the ID tag. There's that number 22. It also shows the outlines of the tags rendered on top of them. If you saw what he was seeing, you would see that it actually overlays on your view. That's augmented reality because your peripheral vision sees through the display, but the display itself shows you these, markers over it, right? So you can see right when the image switch, you can see that there's a couple of different tag IDs in view, and the overlay follows as he's moving.
To give you a first-person view, I'll attach Glass to a camera. When the user taps Glass, a picture is taken and AR tags are detected. The detected tag IDs are rendered in an overlay the size of the original picture. The overlay can be modified directly in JavaScript, opening up a wide range of augmented reality applications on Glass. Subsequent pictures are aligned to the original using image registration. We can then warp the overlay to a picture from the user's current viewpoint, and then, using our prism to camera calibration, which we've described in previous videos, warp the overlay to align with the user's view. This whole process is now run locally on Glass, and the latency has been reduced to about a second.
Now the thing you're not hearing is that this is also doing range estimation. So it's telling you something like range 1.2 meters. So an application of this, I think Brandon asked for some advice from a visually impaired user. So Antonio, here, let's try this. Yeah, I can hold your cane for you. Let me hand you the mic too.
So what I'll do is I'll turn back to the tags here. 1 meter, I'll step back some. 1.2 meters.
Right, this was Antonio's idea that he's not interested in looking through the display, so an even better thing is to have a glass on. It can look right behind him, so this is computer vision on the back of your head.
1.8 meters, watch out steps in range. So I'll step back 1.6 meters. I think that
Wearables open up a lot of possibilities for home automation. I'll show a few examples of what you can do with WearScript. In this example, Glass is controlling the color of the prism and the color of a NeoPixel using Bluetooth based on its orientation. To control a power outlet with Glass, you just need an Arduino, Bluetooth serial module, and a 120-volt relay, all of which can be bought for less than $50. When working with glass, it's important to be mindful of power utilization to prolong the battery life. We have a test rig for this purpose. Glass cycles through functions that we'd like to evaluate for power utilization while monitoring the battery level. Once the battery is drained, it can control its own power socket to charge back up and then discharge to collect another data point. An inexpensive way for the system to know what room you are in is with Bluetooth beacons. Here I can control a light based on if I'm in the house or not. This works slightly different than motion sensors in that you can be still for periods of time without the lights turning off, and can customize the room based on who is in it. Most automation systems are about making tasks easier, but most of them are already pretty easy. An underexplored area is how to make daily tasks more fun. I put AR tags around my house to determine where I'm looking. If I look into the kitchen, a silly video about making juice is played on glass. I can then look at the juicer and give it voice commands. It's controlled using the same setup as before. Juice it up! You're done. Then I can walk up to the mirror. An AR tag above it triggers a video that plays on my laptop, and then glass takes a picture.
But first, let me take a selfie.
That's all we have to share for now. Thanks for watching. To learn more, check out WearScript.com and join us on IRC Freenode in #WearScript. Thanks to everyone who made this possible, including Andrew Miller, Scott Greenwald, Kurt Nelson, Connor Brooks, Lance Fick, Danny Grove, Shane Engelman, Cole Gleason, Corey Kimberger, and the MIT Media Lab for hosting our event. Thanks Will Luera and Big Bang Improv for putting on the comedy show. Thanks Mamie Reingold, Jenny Murphy, Timothy Jordan, and the rest of the Glass team for their support and for making this possible.